Hi everyone, we're going to start off chapter 13 today with a quick lesson on the distance formula and also writing the equation of a circle given a radius and a center. So for the first part of today's lesson, I want you to take a look at this graph below, and in number 1 it asks you to label the graph with any information you recall from Algebra 1 or any other previous math course that you may have taken. So take a minute, pause the video, and see what you can label it with. Okay, so some things I'm hoping that you came up with. First of all, we have this x here, and we should know that this is our x-axis. That's the horizontal axis. This is our y-axis. Another basic is that this point in the middle, point O, usually we'll put an O there. O stands for origin, and the origin has the coordinates 0, 0. Both x and y are 0. Okay, going to the right on the x-axis is in the positive direction. Going up on the y-axis, also positive. So that puts us here in the first quadrant. This is called quadrant 1 with the Roman numeral. And x and y are both positive in that first quadrant. If we go to the upper left-hand corner, this is quadrant 2. And in the second quadrant, because we would be going to the left on the x-axis, that makes x negative, but y is still positive. So every point in the second quadrant has a negative value for x, but positive for y. In the third quadrant, in the lower left-hand corner here, we went to the left on the x-axis and down on the y-axis, so both x and y are negative. And finally, in the lower right-hand corner, that's quadrant 4. And in quadrant 4, x is positive, but y is negative. Okay, so hopefully you recall at least some of those facts from your previous math course. Okay, number 2 is this plot and find the distance between point A, which is at 3, 1, and point B at negative 4, 1. So to plot the point 3, 1, start at the origin 0, 0. 3 is our x value, and 1 is the y value. So go to the right 3, 1, 2, 3 for x, and then up 1. So that's point A. Point B is at negative 4, 1. 1, 2, 3, 4, positive 1. So that's point B. And then connect those two dots to make a little line segment. Okay, so sorry, mine's not perfect there. All right, so between point A and point B, since it's a horizontal line, it's really easy to find the distance. And that distance can just be found by counting the number of squares between those 2 points. So it's easy to determine that the length of line segment AB is just equal to 7. Okay, for our next example, it says plot and find the distance between C at 2, 4. So plot the point 2, 4. So back to 0, 0, right 2, up 1, 2, 3, 4 for point C. And let me scoot this down a little bit. And then for point D, we want the point 2, 7. So we're going to go to the right 2, and then up to 7. 1, 2, 3, 4, 5, 6, 7. Now in this particular case, if you connect those 2 points, you see that we have a vertical line segment. Again, it's pretty easy to find the length of that segment just by counting. Those 2 points are just a distance of 3 units apart. So you can say the length of line segment CD is equal to 3. Okay. So number 4, it says if you are given 2 points which are not on the same horizontal or vertical line, how can you find the distance between the points? So I'd like you to work with a partner. If you see somebody who is free to work with, you can partner up with them and see if you can come up with a method for finding the distance between point E at 4, 3 and point F at 0, negative 1. Before you do that, I want you to take a look back up at number 2 and look at those 2 x values. Look at the difference between those 2. And in number 3, look at the 2 y values and see what you notice as you compare the x values and the distance between the points. Compare the y values and the distance between those 2 points and see if you can make a connection to what we're taking a look at in number 4. Okay, so hopefully you've done a little bit of work with a partner. I'm going to clean this up just a little bit. I was trying to. Let's see what I could do here. All right, won't let me erase all of that, so I'm going to choose a different color and go ahead and we're going to plot the point 4, 3 for point E. So right 4, 1, 2, 3, 4, up 1, 2, 3. Wrong marker. So that's point E, and point F we have at 0, -1, this point down here. So I'm going to connect those to make that line. And what I notice is that obviously it's not a horizontal or a vertical line, but I can work to make this into a right triangle. Right? And the length of this side right here would be 4, and the length of this side is 4. And that means that this little triangle is a 45-45 right triangle. So the distance from point E to point F would have to be 4 square root of 2. Now, I use special right triangles. We could also use Pythagorean theorem. So let me show you some work below. I'll show you how we can find that distance. Okay. So line segment EF is the hypotenuse of that little right triangle that I drew. So you can say EF quantity squared is equal to 4 squared plus 4 squared. Or EF quantity squared, so the hypotenuse squared, is equal to 32. So that means that EF has to definitely be the square root of 32. And that would simplify into 16 times 2, or 4 square root of 2. But you see that using a special right triangle can really help you out. Okay. Remember that anytime we're dealing with a radical, we want it in simplest radical form. So here's the next question. Will your method work for any pair of points? Well, technically it will. You would just have to get into the graph and draw the right triangle, and then find the lengths of the vertical segment, the horizontal segment, plug them into the Pythagorean theorem, and then solve for the length of your hypotenuse. Now, there's, of course, going to be a shortcut. We're going to come up with a distance formula. In the previous question, notice that your first point, E, at 4, 3, I can also label it as being my first point by giving it the coordinates x1, y1. So the ones are just little subscripts telling us that this is our first point. And that point F at 0, -1 would be considered x2, y2. So the length of that horizontal distance could be found by taking x2 minus x1. And the length of that vertical distance could be found by taking y2 minus y1. And let's go up to the triangle, and I can show you that. So this distance right here, from those 2 points, could be considered to be x2 minus x1. Now, it would have to be in the absolute value so that we got a positive number for the distance. And this vertical distance would be the change in y, y2 minus y1. Okay, so this is one leg of our right triangle. This is our second leg. And if we plug those into the Pythagorean theorem, let's check this out. D, the distance between those 2 points, d squared, so our hypotenuse squared, is equal to the quantity of x2 minus x1 squared plus the quantity of y2 minus y1 squared. If we then take the square root of both sides, so the square root of d squared equals the square root of that whole thing, x2 it should be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. We end up with d equals the square root x2 minus x1, so the change in your x values, quantity squared, plus y2 minus y1 squared. So now, anytime you want to find the distance between a pair of points, you can plug those points in for x1, y1, x2, y2, and then solve for the distance. So no more drawing of triangles on your graph. So the distance formula can be used to verify certain properties of geometric figures. Consider the points A at -5, 3, B at 6, 0, and C at 5, 5. So I have a really rough sketch there. It says find the lengths of each side of the triangle. So the length of line segment AB would be the distance between those 2 points. So recall our distance formula is equal to D equals the square root x2 minus x1 quantity squared plus the quantity of y2 minus y1, that quantity squared. Okay, so for the distance between A and B, let's let A equal x1, y1, and B would then be x sub 2, y sub 2. Now, the x1, y1 could be either point, x2, y2 could be either point. So we're going to set it up as the square root of 6 minus a -5, that quantity squared, plus 0 minus 3, that quantity squared. Now just be careful. Watch that addition and subtraction. That's where the majority of mistakes happen on distance formula. So 6 minus a -5 turns into 6 plus 5, which is 11 squared. 0 minus 3 gives us -3. So we're going to square that quantity. So AB has a length that's equal to 121 plus 9, or AB is equal to the square root of 130. Now I'm going to leave it as just the square root of 130 for now. We'll talk about whether or not to simplify or try to simplify radicals in a second. Okay, the next line segment we'll find the length of is line segment BC. So BC has a length equal to 6 minus 5 quantity squared plus 0 minus 5 quantity squared. So 6 minus 5 is going to give us 1. And 1 squared is still 1. 0 minus 5 gives us -5, but when we square it, we get positive 25. So BC is equal to the square root of 26. So hold on to that thought for a minute or two. Okay, finally, the third side we have to find the length of is AC. I'm going to squeeze that work in over here. So from A to C, so first point to last point, the distance would be the square root of 5 minus -5 quantity squared plus 5 minus 3 quantity squared. And again, be careful with that subtraction. This actually turns into addition. So 5 plus 5 is 10 squared. 5 minus 3 gives us 2 squared. So the length of line segment AC will be equal to the square root of 104. Okay, again, that can be simplified, but just hold on to it in this form. It'll make our work a little bit easier. So the next question says, verify that the triangle is a right triangle. Well, it will be a right triangle if the sides work or make the Pythagorean theorem true. So the longest side we have here is line segment AB. That's got to be our hypotenuse. So that will go in for C. And so we're going to take and plug these values into the Pythagorean theorem and see if it works. So we have the square root of 26 that we're going to square, plus the square root of 104 squared, and we're going to see if that's equal to the square root of 130 squared. And now you see why I didn't simplify the radicals, because just squaring these radicals means that we'll have 26 plus 104, and you can see that that's exactly equal to 130. So it is a right triangle. Okay, it says find the area of the triangle. The formula for area of a triangle is 1/2 times the base times the height. The base and the height have to be perpendicular to each other. So AC and BC are the two sides that are perpendicular to each other because we said that AB was the hypotenuse. So we're going to take 1/2 times the square root of AC. Oh, sorry, we're going to take 1/2 times AC, which is the square root of 104, times the square root of 26, which is the length of line segment BC. Okay, so when we multiply this out, it just comes out to be 26 square units. And you can use your calculator for that. Just make sure when you hit that square root key, know that your calculator puts parentheses in. Make sure you close those parentheses. Okay, so something new. You may have discovered or talked about the distance formula in another math class, but you probably didn't talk about the equation of a circle. Okay, so we can use the distance formula to help us derive the formula for the equation of a circle. So if we take a look on this graph, we're going to put our x-axis and y-axis in the upper left-hand corner. So y-axis, if you could put it way over here. There's your y-axis, and put the x-axis up here as well. So we have this point, 4, -3. So graph 1, 2, 3, 4 to the right, down 3. So that's our center. Okay, so again, its coordinates are 4, -3. And we have a circle whose radius is 3. So what that means for us is that we want to go 3 units away from the center in each direction, and then we're going to try to sketch the graph. So if you start at your center point, count 3 to the right, that would be a point on your circle. Come back to the center, go up 3, 1, 2, 3, that's another point. Back to center, go left 3, that's another point on your circle. Back to center, go down 3. And you've got 4 good points on your graph. So we use the highlighter tool here to just kind of highlight where our circle would be. So bear with me a second here. Okay, so do your best to kind of connect those points and make a nice smooth circle. Okay, not too bad. All right, if we choose any point on the circle, then we can say find the equation of the circle by taking a look at the distance between the center and some point called x, y on the circle. Okay, remember that that distance from the center to a point on the circle is called the radius. So think about our distance formula. So it would be d squared, or r squared, is equal to x minus 4 quantity squared plus y minus -3 quantity squared, or r squared is equal to x minus 4 quantity squared plus y plus 3 quantity squared. Okay, so our radius in here, we can solve for it. If we need, well, we're given the radius is 3, so we're going to plug 3 in there and have 3 squared equals the quantity of x minus 4 squared plus y plus 3 squared. So final answer would be 9 equals x minus 4 quantity squared plus y plus 3 squared. Okay, the important part about this is that we come up with the general formula for an equation of the circle with a center at a comma b and radius r. Now notice that in this little formula it says x minus 4, but x was positive 4, so the sign is always going to be the opposite. Here it says y plus 3, and the sign on y is -3, again the opposite. So in general, the formula for the equation of a circle with a center at some point a, b is going to be x minus a quantity squared plus y minus b quantity squared is equal to the radius squared. So take a look at number 8 with me. It says find the center and radius of the circle with this equation, x minus 6 quantity squared, y plus 1 squared equals 9. So compare it to our equation up here, our formula. And we notice that this says x minus 6. So the x-coordinate of the center needs to be the opposite of negative 6, which is positive 6. This is y plus 1. The y-coordinate of our center would be the opposite of positive 1, which is negative 1. So the center is at 6, negative 1. And now the radius, r squared, or the radius squared, is equal to 9. Therefore, our radius would be 3. Okay, so finally for today, see if you can answer these 3 questions. Find the distance between negative 6, 2 and 2, negative 4. Identify the center and the radius of the circle with a given equation. And finally, for number 3, write the equation of the circle with center at 2, negative 1 and radius at 3. And see if you could sketch a graph. For this graph, you can put your x and y axis right in the middle of the graph. Okay, once you've tried those 3 questions, please tear off that last sheet of your packet and turn it in to me. Make sure your name's on it. All right, good luck, everybody.